Yeah. Hello, class. Good evening, everyone. If you can hear me, good evening, good evening, good evening. I welcome you once again to this edition. I think we're already running up. We're running up on the AIML. Good evening, good evening, good evening. If you can hear me, I want to see you on the comment section. Good evening. If you can hear me, say yeah, or just type yeah. Yeah, good evening, sir. Mr. Shegun. Good evening. Mr. Shegun Bello. Good evening. I think we have an appointment. Good evening, Gabriel. Adebisi, good evening. Good evening, Francis. Yeah, thank you. Good evening. So I want a good number of us to join before we start for this evening. Yes, Mr. Shegun. Yeah, we have an appointment. I have not forgotten. Good evening, everyone. Precious, good evening. I know my people. I know my people. I'm looking for Isaac. Yes, Isaac. Where are you? Yeah, Bars Jeremiah. Good evening. Good evening, Louise. Good evening, Innocent. I think that people have not mentioned their name. Isaac, yes. Good evening. You're welcome. Josephine, good evening. Lovett, good evening. While we are waiting for others to join us, make sure you have opened your Jupyter notebook, your Anaconda navigator, open everything. So I think we are rounding up. By next week, we should be able to develop something and then start our mentorship class next upper week. Right. So while we are preparing for that, this class is going to be somewhat great. Let me say great. Yeah, good evening, Light. Good evening, Favor. Yes, good evening, Favor. Where is Praise? I've not seen Praise. Praise, where are you? Good evening, Shegun. Matthew, good evening. You're welcome. You're all welcome. Thank you for still holding forth in the class. So for this class, we will continue for where we stopped last week, for week 5. I believe the admin is already on our LMS platform. You can download the code. I'll work on the code again. I think I'm still going to still share it. I'll work on the code again. And we can just use that one to play. Yeah, use it to play. Good evening, Benjamin. Good evening. Good evening, Felicia. Good evening. Thank you for joining us once again. I think we're okay. We're good to go. We're good to go. So my name still remains Blessing Olonfemi. Blessing Olonfemi. I'm a AIM engineer. I develop model. I also fine-tune model for client tasks. Anything you want to use to do, you want to work with model in finance, you want to apply it in finance, you want to apply it in health, you want to apply it in politics, anywhere. I believe I can work with model, apply it on that, like on any platform. So I major in health based on that's what I'm doing working on presently on my research work. Right. Yeah, good evening everyone. So we'll continue from that again. Then I will be showing all these slides, just about 7 slides, just little introduction. Then we'll do the week 5. I think we stopped at confusion matrix. function matrix, we're talking about TP, TN, FP, FN, and now we can calculate that. And I said that we should use different algorithms or model. Algorithm is coming in, then when you start training, you now start using model. Again, I will say I'll be saying a lot of stuff, a lot of things that is not in this slide. Although be saying it, you can be penning it down, you note it down. On Wednesday, somebody was asking question about how are we going to deploy the system. And I saw somebody saying Streamlit. Streamlit, yeah, Streamlit is simple. You can use Streamlit. Then another person was like Flask also. So we use Streamlit and Flask to deploy our system, right? For next, if you can finish it, if you can finish today's class, we're good to go. Or if you can develop something, start developing something today, like deploying it. Or if you can, see you next week. Yeah. Good evening, sir. Peace. Okay, yeah, peace. Cell not executed due to pending input. This is what I get when I try to run my code. I have to rerun the kernel and still repeat. Yes, yeah, for peace. You have to rerun your kernel. Maybe we'll look for a day that we are going to like a meeting, a family meeting. Everybody will start running. If you have any issue, we're going to start working on it. Okay, do it like this, do it like this. I don't know. Maybe that will be during the mentorship class. Right. So okay, here in Dorcas, I've seen Dorcas. Viola too. You're welcome. Welcome to our class. So hyperparameter tuning, and the objective for today's class is we want to understand hyperparameter tuning method, apply hyperparameter tuning to improve model performance, compare the different tuning techniques up to successive halving, right? Then demonstrate tuning results with practical example. Community meeting when it is yeah, we'll try to look for a day for a community meeting, because I'm seeing a good number of people interested in this, and then I want us to this hands-on practical. I'll look for a day if possible. God will help me. So then while we're doing a hyperparameter tuning, we're still going to see it in our I did a little bit description in the code, inside the code, a little bit description. I'm still going to share it with us again. We will upload it on LMS, but LMS is just for us to go there, download the code, still do what you want to do, right? Then I'll be explaining some stuff. I mean, some of you will have been running the code already. We need explanation on what to do, and we're having error, right? So how did I call it? I didn't see. So our parameters. So we have input model accuracy, optimized learning rate, depth, estimators, etc. Find best parameter combination. Our parameter tuning is this is what they call AI. This is the AI part. You are fine tuning. And then you want to be like an AI engineer or expert. You need to deal with messy data sets, right? Start like you want to work on data sets, then start fine tuning, start transforming, doing everything you want to do, right? So I still not have access to my LMS. How do you want to do it by you? I see. How should I pronounce it? Okay. So common parameter tuning that we have the manual tuning. We have the grand search CV tuning. We have the random search CV tuning. We have the Bayesian optimization tuning, that is for Optunam. We have Optunam. We have the APAOPT, that is tree structure tuning. We have the genetic algorithm tuning. What is successive halving tuning? So some of these are in scikit-learn that we've downloaded. In scikit-learn that we've downloaded. in this class, I'm still waiting for someone. I've not seen her. Faith. I've not seen Faith. She has been asking me question. I've not been able to reply on the one of my platform. So I'm waiting for Faith. If you know Faith, please tell her to come online. Faith and then okay, I've seen Shegun. Shegun have come. Wait again. I think Ibiola. I'm waiting for Ibiola too also in this class. Abimbola. Yes, Abimbola. Yes. I think you messaged me, Abimbola. You fucked on something like that. But it's the same thing, Mr. Paul. Or fine tune you have applied a papa to me. Like you'll be seeing it, Mr. Paul, you'll be seeing it. Right? Okay, okay. Sorry. Mhm. Okay, so this we'll be working with all these Apapanta tuning. Then I'll be dropping this slide soon. I'll be dropping this slide to show you my code, right? And then we'll be talking about it one by one. Generative algorithm, successive affine. Um, then so everybody open your Anaconda navigator. Then Jupyter notebook. I want to see if you have opened it. Say yeah, 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 yeah. If you are on Jupyter notebook, say yeah, yeah. Okay. Yeah, thank you. Yeah, 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 yeah. I want more response. Before I drop this slide, I want more response. More response. My voice no faint. I'm just waiting for everybody. If you have dropped your slide, divine favor. I'm waiting for everybody. Booting, okay. Abimbola said booting. I'll drop my slide soon. Shall we continue? Yeah, okay, okay, okay. Thank you. Thank you. Yeah, yeah, yeah. Okay. Okay, so right for that. Thank you very much. At least if you know how to open an Anaconda Navigator, then open Jupyter Notebook in this class. At least to some extent, we are good to go. That's Steven. Okay, wait for you. Okay, let me upload my slide now. Bring up my slide, my um notebook. So we'll continue from there. Um, Can you see my screen? Is it clear? Or I should still bold it? Is it clear? Divine favor, what's happening? Why are you crying? If you can see my screen, please. Yes, okay. I think I still need to bold it. Yes. Yeah, doing more of theory as the laptop was stolen by robbers. Just with, hey, sorry, divine favor. Sorry. Um, but you have laptop, you can still use Google Collab. Google Collab. Yeah. So someone said your something is still loading. Better now. Okay, thank you, Shegun. Thank you. Yes, okay, thank you, admin. Let me save. You can be using your phone for, I think, Pyandroid, just to doing one or two Python stuff, divine favor. But for um to run this type of algorithm on your phone, I don't know. You're not gonna blow your phone. No. Yeah, sorry. Praise, you're welcome. Yeah, I'm looking for praise. Praise in Olua. You're welcome. I mean, Bola, you're welcome. Yeah, thank you. Where's Isaac? Isaac, have you opened your system? Isaac, where are you? So I'll be explaining. I believe for some of us that have access to LMS, we downloaded this code and then also the slide. The slide is just about seven slide, not seven slide. So I believe we have downloaded it. Then you put the code inside the folder, DSA folder that you've created on your desktop. On your desktop, put it there. Yeah, you're welcome, Isaac. So I'll be explaining how it works and what we want to do. But first of all, what we want to work with before we go to hyperparameter tuning is I need to explain convolution matrix. I need to explain convolution matrix, and I'll ask us question. Right? I'll ask us question. If you can get it, you go to hyperparameter tuning. I tossing go for time. Yeah. So all is well. Um, I can see this one, but I have opened it down. Okay, correct. And put the when you see the code, put the code inside DSA. Then go to Jupyter Notebook. Go to Jupyter Notebook. Go to desktop. Then DSA. Look for the code. Open it so you can play with it. Now, week 5. I think we are done with 5. Then I did some little addition. Again, just a little bit vision. We are working on focusing on I am applying ML on a particular data set, which is diabetes similarity data set. Then we've seen different type of pictures, right? The age, the glucose level, the BMI, body mass index, the what again? That I've not talked about with body mass index and like that. Different pregnancy, glucose, blood pressure, skin thickness, insulin, and the likes. Then we see the way you can visualize it, right? How to visualize your code, your data set, right? I came in a little bit late. And yeah, we just started. Mr. David. You're welcome. So how to visualize your code and your data set. So we were working with diabetes mellitus data set. Then some of you have been reaching out to me that can I work with this type of data set on finance. I was like, okay, you are good to go. Since so far is CSV, Another person reach out to me, can I work on this data set and add prediction something? I think it down me. She reached out to me too. And there's this other guy that is working on ATM finance. Reach out to me and like you're good to go. Play with the data set, generate what you want to generate. And they have been having different insight, asking questions, right? So we've done all these parts, the data shape, then the information. There's someone that reached out to me that says that he's seeing something like object, not integer, not float. So object is more of string. Like I think some of the letters there are not letters, right? They are letters. So we are seeing object, just know that your data set contains more of letters, right? So we've done all these parts, df, describe, and yeah, blood pressure, yeah. So we've tell me why. Tell me why. Why are you lost? So lost because every 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 time I want to take this class, I will make sure I go back over and over again. So you shouldn't be lost. Tell me why. You shouldn't be lost. Every time I make sure I go back over and over again, another revision to make sure you understand what you are doing, right? So you shouldn't be lost. So tell me why you're on LMS. You can't get the data set. You can always watch again. You'll get it. Thank you, Jumoke. Thank you very much. So, yeah, you'll get it. You will get it. Just sit down with it, pause, play, do what you want to do with it. Then DF describe. We talked about some. We have seen a lot in this stuff. Sometimes we don't even need to explain all these codes, but we just need to understand because we then we this place those to check for numbers that you need to replace a zero um with none. So we're checking for number that are contain zero. So we place a zero with none value. I believe you have this week 5 something on with you. Then visualization EDA. So EDA from here we have seen zero means we set it 0 and 1. So we saw that um the people that don't have diabetes is zero and no diabetes, one means there's diabetes, right? Just like benign and malignant. Oluwole was talking about, I think SS3 in his own time was talking about benign and malignant. And then some other people that are working on maybe on finance, you want to check for attacks or not attacks, or you are working on spam detection system, or you want to work phishing system. I'm already giving us expo actually. I'm giving us expo for some of you that want to work on phishing, want to work on spam, want to work on finance. Like finance now is um, like fraud detection system, ATM system, all these things. You get the data set on cargo, inside cargo, yeah. Check cargo, you get data set there. Just type what you want to do. I believe you get data set. And then in another way again, you get these guys, there's guys that have worked on all these things. So there's a way you can now understand and manipulate your own data set, manipulate your code, right? There's a way you can manipulate your code. I have been trying different ways in boosting the accuracy, but cannot enter. We'll see what we can do about that. Sammy, we'll see what we can do about that. Let me ask one question, Sammy, if I continue. For Sammy, what data set are you using? Data set are you using? Because this is where it's so much trickage. And last week, I said a lot of stuff. In week 5. I'll be giving a expo already that. So when you are doing your own work, using different type of data sets, you just know what to do. Oh, Mr. Blessing have said this. Oluwole have said this. Isaac said this. Okay, let me apply it to this stuff, right? So this one is visualization, skin thickness, just to visualize all the data sets. I love glucose. Glucose is somehow aligning well. Everything's aligning well. It's not separating. Pregnancy is separating somehow. Blood pressure is not separating like that. But it's still appliance. I'm looking at it now. I'm looking at some appliance outcome. There's some appliance. Okay, the outcome is the target variable. The age, there's a lot of appliance, and then we've done how to work on appliance. Like if I'm the one to write this code, using .py. I don't need all this visualization, this small data analysis, right? You want to visualize, see what is happening in your code. You want to see what is happening. You want to see the people that have diabetes, people that don't have diabetes. You want to do bar chart, the pie chart, plot charts, Instagram, everything like that. So, and like correlation, I said that most times you use correlation to check. Is it most times? Or yeah, you use correlation to check um, the high features. High features. So from here, I can pick my high features correlated with outcome. Right? I can just pick my own high features that I want to work with in this work. Right? I can just pick three, maybe glucose, insulin, and age. I'm good to go. Right? I can pick four. And then today somebody was presenting in one of our presentation. I was in a meeting today, and the person was like, after they finish all the presentation, somebody was not presenting on diabetes mellitus. And the person was like talking about pregnancy, and like, she do we have transgender now? She, if you want to check for that, like a guy now, you want to check if you have diabetes, maybe using your app now. They'll be asking how many pregnancy do you have? So I was asking the person. So there's a way you can work on that. Work on that. So that's for that. Then just revision. Median to replace zero, then your scaling, your scalar, and then I explained last week, I'll divide your data set into train, test, train and test, right? Train, test. And again, if you want to still maybe work more of your data, you divide it into what they call validation, train, test, validation, train, test, validation, right? So we've seen the random state to reproduce to make sure the data set is consistent, and also for certify too. And everything is there. Check your LMS. You'll see then the description. I have the description there for you to go over and over it again. Then last week again, started talking about model. Lowly was talking about model. Then Isaac started talking about model. Then I said, all this model we are doing, okay, normal. If I just call my model in scikit-learn, is a library, like from SK linear model, import logistic regression. Import logistic regression. So not necessarily that you want to be seeing something running. It's except you are doing deep learning model. Right? Deep learning model, you'll be seeing epoch and the likes. Oli was saying something. If possible, we'll introduce deep learning model. Well, that one is another topic on its own. So for sklearn, just one algorithm. You see, and then the classification report, confusion matrix, and then the accuracy score. Now, for sklearn, this logistic regression, from sklearn, I need logistic regression. And last week, I think I was asking us what type of algorithm, different type of algorithm or machine learning models. Let's say models now, machine learning algorithms or model. And you be mentioning logistic regression, you mention random forest, you mention decision tree, you mention XGBoost. They are all machine learning model. Now, we have model is equal to logistic regression. This logistic regression here, this logistic regression model is equal to logistic regression. Then train this model, fit this model, that is to say this model here, come down and fit it inside my S train and Y train. S train and Y train. That is to say my features and the outcome. My features and the outcome. Train them together. So no need of seeing anything. When you do this, it's already training already. It has trained your data set on the model, right? You have trained your data set on the model. Okay, I've watched them all. Then keep tell me why you have to keep watching. Just try your best. Then tell me why. If you're on LMS, is it LMS? I think there's a link. We make sure that there's something called Introduction to Programming, Python, right? Very easy, simple. You can download it, just learn. When you're doing like variables, X plus Y plus C, before coming to all this type of code. So very simple. Make sure we did that. All the materials on LMS. Okay. All the materials are on the Okay, okay. Just go there. All the materials are there. We download materials that you can play with. No need of stressing yourself. Okay, so that is for that. Then fitting. Then the prediction predict those people have diabetes and not have diabetes, and then we add 70% accuracy. 70% accuracy. And I said something last week. I said if it is last 4-5 years ago, they are presenting 70% accuracy to me as a student, I am okay with you. I'm okay with you, but you are presenting 70% accuracy for me now, 2025, where people are even getting 100%. Neither is overfitting or 90 something or 80 something and above. I will like somehow be I will like, I don't know if I'm going to even collect it, right? But if you are presenting 70% accuracy for me and maybe a little bit higher, maybe 70 something, maybe 70 something, 77, 78, and it's okay. It's okay. I might collect it. Then there's some stuff that is missing. Now I want to be saying some stuff now. You can be noting it down. From the data set, I think Oluwole said something about smooth, undersampling and oversampling. Undersampling and oversampling. Yeah, undersampling. Yeah, undersampling and oversampling. Yeah, sampling and oversampling. Like you to say, balancing of data sets. Balancing of data sets. Now, looking at this logistic regression, you will discover that the model from here, precision, you will discover that we have more or non-diabetes is 0. No, we put 0 to be non-diabetes and 1 should be diabetes, right? 1 should be diabetes. No, it's not underfitting. It's smooth. SMOT. SMOT, smooth. We'll be talking about that. I'm already giving us I'm giving us expo already on how to increase your accuracy. I'm giving us expo. So let me come back. You will discover that on precision, we have all of them there, they're high. All something there are high. Like for precision, we have 0.75 for precision. For recall, we have 81. Though it's okay. It's okay, 81. For F1 score, we have 78. Then for one, in case you ask to explain this, but for one, is 0.59. It's very, very low. It's very, very low. It's not saying it well. Like it's not learning well. Then 0.50. Then 0.54. Then for some of you that are asking question about support, is testing. We said that last week. Testing 100 plus 54 is 154. Then we went back here to look at, okay, when we divide our data set into train and testing, the training and also the testing, right? The training is 614, the testing is 154, using just this one line of code. Just this code is dividing our data set into 80-20. And remember that we have 768 or so total instances. So it's dividing it. So this is where, again, I used to like catch some of my students. Okay, you are fine-tuning your model, you are training a model or algorithm on a particular data set, and you are telling me that the total number of okay, let us say we have total number of data set 100. We have 100 data sets. Then we divide it into 80-20. So let us say 80-20. That is 80-20. Yeah, 80-20. But what I'm not seeing is when you not test the algorithm, I'm not seeing like 10. I'm seeing like 10. I'm not saying that your accuracy is something maybe you have high. That means the person have do mago to the stuff. So these are the something that we need to work on. Now, this is another expo. For this, I'll go back to my data set. I'll make sure I clean it more. I'll do my preprocessing more. There are still different and plenty way to preprocess your data set. Apart from the median, the imputation or mean that we taught you, right? There are different way to preprocess your data set. So this way you begin to do your research. Okay, there are different way. Let me work on it. Then there's another thing called smooth oversampling and undersampling. Like one is bigger than one. Can I balance it? If I balance it so that my model can see more of this one and more of this one to avoid underfitting or to avoid overfitting, right? So I'm making sure that I'm explaining this more, like I'm taking my time. This is what they call model fine-tuning or model, or okay, we have not reached fine-tuning or parameter tuning. But this is where you need to be careful now, what you are doing, right? So you can always go back to your data set and pre-process and pre-process. Then if pre-processing is not working, then that's where you will now have another way of working on your data set to make sure you don't concentrate on accuracy alone. Actually, every data set and everything you are doing, every data set or everything you are doing have their own evaluation performance. They have their own evaluation performance. For most classification is accuracy, and regression is more of a R square, root mean square rows, and the likes. We're supposed to see that. That is when you're using you want to work on house prediction price. Yeah, you want to predict price in anything price in finance. You'll be using house square and then like yeah, thank you. 768. So it's correct. That support is correct. We'll divide it by test. Okay, so I believe we understand. I believe you understand what I've said, and you have noted this down. I believe you have noted this down. So now we will continue from where we stop. Please note this down again, over and over again. I'm saying a lot. I've said a lot, a lot. If possible, if you can come back and listen to this, to what I've said, you are good to go. You are just good to go. You are good to go. You don't need to stressing yourself again. Just be collecting work from clients and make sure you are paying your tithe to my account. Just make sure you just call me. Yeah, look for my number and make sure you pay your tithe to my account. Now I said this is something in first class that just visualization we did. One client like that called me and they were like, "Can I just do visualization of my data sets? Just visualize it, please." And I think he paid in one amount, right? So yes, prof, yes. So that's for that. So then we also this confusion matrix. Oluwole was trying to explain this, and then I think he still messaged me that I should complete confusion matrix, and then before we go to a parameter tuning, right? So I'll take my time to explain today. So now for this confusion matrix for see something now. I put something here, suggestion to improve diabetic detection, the class 1. Try balancing the data set using smooth or class weight. Yeah, class weight. Now, this class weight is for the model, class weight model. If you use class weight, you'll get higher accuracy than smooth. You can try it. Don't try it. Try it. Play with it. Right? If you use class weight, you can get higher accuracy than smooth. We are working on a paper right now. Then we are testing class weight and smooth. Class weight and smooth. Then we discover that class weight gave us. So this is just trying and error actually. If I put this in here, if I remove this one, if I put this one, I mono this one, and the likes. She gets me. Then consider using another algorithm. Now, a client will call you, or somebody will call you like, "Oh, guy, I saw something on LinkedIn. You put something on LinkedIn that you are not to visualize. You're already applying model. I saw this and this one like this. Can you use so algorithm so? You only like you just calm down like this algorithm cannot work with this data set too. So that's why you start schooling them. This algorithm cannot work with this type of data set. Or so like you just start schooling them. If you are getting. So this is more research. Like just still go back, do your classwork. Though everything we're doing is not that maybe you're still going to do like plenty research like that. So I said something that use XGBoost, use random forest. They are decision trees, like more of the combination of decision trees, XGBoost, random forest, combination of decision, like support vector machine, naive Bayes, and the likes. Then you can tune a threshold for prediction in your work. with glory. Okay, so now let's see something. Commission matrix. So we have 81, 19, 27, 27. We're answering this question. I'm taking my time again, like again, after this one, go to Papa down to me. So we have 81, 19, 27, 27, right? Then let's go down. I did like a description down here. So we are going to answer this question. Then, for example, this confusion matrix, this is a confusion matrix something that Oluwole have taught us, right? But we still need to get it ourselves. So that it's one, so it's one, that is Tn, two negative or two positive. I can as well bring this actual yes, bring it up. Then this actual no, bring it down. Then change this one again. But don't be confused. They call it confusion matrix, but don't be confused. But from here, we can pick our errors. We can pick if the model is doing well or the model is not doing well, right? Model is doing well or the model is not doing well from here. Now we have two negative, we have two positive, we have false positive, we have false negative. Now going back to this confusion matrix here, which from this one here, I want Isaac to answer this question now. So which one is my two positive, two negative, false positive, false negative, and false? Okay, let us start with two positive. Everyone, which one is two positive? Which one is two positive? Which one is two negative? And which one is false positive and false negative? Right? I'm not seeing anyone. Okay. Felicia, two positive is 84. Okay. Two positive is 84. I think I said I want to be giving gift to like free credit in my class. Maybe in my next question. Yeah, I'll be giving free credit. I'll tell you where to contact me. Okay. Okay, two positive is 84. False positive. Okay, wait, let us do something first. Let us go back. Everybody look at it. Look at it. So I said that let us do like this. Okay, now it's upside down now. Upside down. So our two positive is this TP, two negative is this one, false positive is this one, false negative is this one. Right. So I'm going back now. So you won't miss it. You won't miss it. But I said when I now change it, that's when you know that this place is too positive and negative. So don't miss it too. Now going back to this confusion matrix for AGBoost. So which one is our two positive? Which one is our two negative? And which one is our false positive? Okay, now let me start. Two positive is 34, correct? Okay, yeah, it's not correct now. I think if now if it's not correct now, correct. Correct, do sure. Okay, what of false negative? False negative. What of false negative? Which one's our false negative? Which one is false negative? 34. Two positive is 34. Okay, false negative 16. Okay, yeah, great. 16. Somebody said 19. I'm saying 19. Is it mistake? Colade, is you have 19 on this part? Colade, come and explain to us. How do you get 19? Come and explain. How do you get 19? Okay, 34, Emmanuel 34, 84, 16. Correct. Okay, Emmanuel don't finish everything. VAR. Last 16. Beautiful. Now, that is confusion matrix, actually. Don't be confused. Sorry, mistake. Okay. Because I was like, Colade, where do you see okay, false negative. False negative 20. False negative 20. We'll check it. I think, yeah. Divine. Yeah, we'll check it. Okay, beautiful. Now, I love this. You should have people following. Then for those that are not following, I think better maybe looking for. Yeah, I'll explain. I'll explain. But for those that are not following, please try your best to come back and do revision. Like just do revision, look at it over and over again. Some of this online something that I've joined, they don't explain like this. You have to sit down to look at it. Maybe because I'm doing research. So now a coefficient matrix is a performance evaluation tool for classification model. It compares the actual true value with the predicted value from your model. Now we have the two negative. See, the two negative is this. This is those actual what do you call it in coefficient matrix. Now the two negative correctly predicted no, that is 0. Correctly predicted no for the two negative. This part, let me put it down so that you see. Now we have the two positive, which is that 30 something that we look at here. This one here, 34. It's saying that it's correctly predicted yes. That is to say, our model predicted it positive and it's actually like that. Yes. And one is what? One is diabetes. So it's telling us that our model picked 34 patients. They have diabetes, and the model is actually saying it is yes. Quality predicted it, and the model is saying it is yes for 34 patients inside 154 test data sets. How did I know it's 154? If you calculate all this together, see 84 plus 16 plus 34 plus 20. Can you give me the answer in the comment section? 84 plus 16 plus 20 plus 34. Give me the total answer. You will discover that it is 154. Now, so he's saying that correctly predicted 34, but this model predicted it's positive, and it's actually it is. Now, for the true negative, from the name, you will have known. True negative. Correctly predicted no. Correctly predicted no. But the model, in the actual sense, the model predicted it's negative. And it's actually like that. It is actually like that. Now, that is to say, both TP and TN, true positive 34, and TN, they are true. The model is doing well. It predicted it well. It's actually like that, right? Even from our classification report, you will discover that our model is doing well more on 0, more on non-diabetes. If you are working on spam, all these things, is doing well more. Yes, that's why it's even higher. Please don't be confused. So now 150, yeah, correct. 154. So now for false positive, it's telling us that it's false and it's also positive. The total number of maybe the patient that are false or the model pick that are false and it's also positive. That is to say, incorrectly predicted yes, model predicted positive. The back end, if you get positive, but in the actual sense, it is negative. So this is where when you're hearing about false positive and false negative, you're hearing about type 1 error, type 2 error. It's a gap. There is such a here. You can fix it. Okay, let me work on type 1 error and type 2 error. Then you explain. Because people like all these things that is somehow tough. And you are able to come out and like, no, I'll explain this, I'm going to solve it. So you can come out and solve it. Like, what can I do to solve it? We're going to Hyperparameter to we see if we can solve it. But with that Hyperparameter that I worked with, it was not able to solve. But I know where the error is. Right? So that's an assignment for us. Then for type 2 error is false negative, incorrectly predicted no. That is to say, the model predicted negative, but in the actual sense, it is positive. Hope we are not confused, but we are confused. Hope you are not confused. If you are good to go, say yeah. If you are following me, say yeah. If you are with me, say yeah. So now, if you know two positive, two negative, false positive, and false negative. Joel say yeah, correct. Bola, okay, Ogun today say yeah. Yeah, Gabriel say yeah, correct. So with this one, we are good to go. I'm happy for understood. Yeah. Thank you, Mr. Shegun. Thank you. David, thank you. Thank you. So with this, nobody can come and bamboozle you again. And then for some of you that is we are starting, you can start, post it on social media. Oh, I know how to, confusion matrix. You can even explain to people. Then when you see any confusion matrix outside there, a model, you should be able to explain, oh, this one is this one, this one is this one, this one is this one, this one is this one. So start putting outside there. You're already developing model. You're already training your model already. And it's when you are start applying it, right? Yeah, thank you very much. Please, everyone, thank you. Thank you for following. Hey, now let's just, we have just 6 minutes more to break. 6 minutes more to break. So, because I want to concentrate on the, yeah, I did. Francis, I did. I just add this description to it, the last part. So we might share it with us, or just the link. I think Jumoke said the link to can go there with 5. The update one can work with it. Yeah. Thank you very much, Isaac. Everyone, thank you. So that is for that. Then it has a formula, accuracy. It has a formula, TP plus TN. Okay, this is a wrong formula actually. This is a wrong formula. And for accuracy, it's very wrong. No, okay, this is the right formula. TP plus TN plus FN plus N divided by TP plus TN. You get the accuracy. So that is to say, this formula, this formula here, if you are done with this formula, you should be dating this accuracy that we're getting is 0. something here. What is 0.70? You should know how to catch your, maybe you want to take somebody, you should know how to catch your student. So some of us now, if you start submitting your work, this way I will catch you. This I was like, oh, this person that do this thing, how did he do it? So we have 50 plus 35 TP plus TN divided by 100. That is total number 85. The F1 score and like that. So that is all for confusion matrix, evaluation, performance, precision, the F1 score, and recall. If you are working on health, most times we use recall, sensitivity, specificity. If you're working on finance, then you'll be using maybe like number, numeric. You'll be using R square, root mean square. A lot of all this one is just, I'm just saying this, but it's a lot. You can just do your research. Okay, this thing I want to work on. Then just not to do your code. And again, thank God for the likes of LLM. Right, thank God for the likes of LLM that you can always ask questions. I want to work on something. And like now, let's go to our today's class, and we are good to go. Baraka, why you close your mouth? And Paul, I don't know why you're not on LLM, LMS. Why? So week 6 is still same thing. Hyperparameter tuning, and I've said we want to work with hyperparameter tuning. Then my focus for today is random forest. I work with random forest. Then okay, I'll give us assignments like inside that code, or like a classwork. Inside that code, you should apply naive. We should not use ensemble model. Apply naive. Let's see what it's going to give us. Then again, I remembered someone talked about Streamlit. Yeah, we'll use Streamlit in our next class. Looking at this, let me ask a question before Hyperparameter tuning. This phone is for what? Let me look at it. This stuff is for what's 73? Random forest. Yeah, random forest. This random forest. What's our TP? What's our TN? What's our FP and FN? Please together, do it together. Just together. What's TP, TN, FN, FP? TP, TN. Good evening. Yeah, good evening. You're welcome. TP, TN, FP, FN. What's it? It's different from 84, 20. Like, so I want to see who get it. Felicia, yes, we are using week 6. Yeah, yes. I'm just doing recapping confusion matrix. Confusion matrix. I didn't explain confusion matrix last week because of our time. Right. So I just I'm in week 6 now. Week 6 now. Oh yeah. Noted. Okay, TP 64, TP 64, TN is 161, FP 40, FN is 43. Um, correct. TN. Oh, this is beautiful. There's another question I want to ask. That one is free credit. Free credit. This this awesome. This awesome. People who actually know it. That is great. So we're going on break. We're going for break now. We're going for break now. It's so just I think during the break you will have time to take your attendance. Then we're coming back to apply hyperparameter tuning. Just learn about hyperparameter tuning. Then I'll answer one or two questions again. Apply to your code. See what it's going to give you. And call it a day next week. So yeah, this TP is 64, TN is 161, FP is 43. Okay, now time for break. Time for break. We'll come back. We'll discuss more. No, Ada and Dada still. No, I've not said. I'll attach the question with the free credit. I'll attach the. Yeah, welcome back, everyone. Okay, Smadi with SG boost, the accuracy of diabetes is still lower than non-diabetes. Why, sir? First, the data set. Data set. Right. Um, try another model. Try another model. Just look for another model and try it. Then work with it. Right. So I believe we have done with our attendance, and we are good to go. Okay. So yes, Monday. So thank you for the answer. TP, TN, FP, FN, two positive, two negative, false positive, false negative, and the likes. Thank you very much. Thank you. So now you can explain that what the model is predicting, the actual, and then the false negative, the type 1 error, type 2 error, and the likes. So now we have edge boost. Normal is 73. For logistic regression, is it logistic regression? We have 70 up there for the accuracy. I'm just concentrating on accuracy. Maybe if time permits, we'll be talking about precision recovery and concentration on accuracy for um this class. Right. What is the criteria of determining which figure goes for FT and TPTN? I think I've mentioned that in the group 5, like two positive predicted versus the actual, predicted versus the actual, depending on how you want to do your confusion matrix, right? So every confusion matrix I've showed us, I think I showed you, it's like this. Every confusion matrix is um yeah, open. Why are you blank? Just predicted value versus the actual, right? Okay, yeah. Usual value versus actual. This is it. So we have predicted yes, predicted known, actual, and actual. Then inside, that you bring this one up here, can be yes or no, anyhow you want it. Two positive, two negative. But for this stuff, we are using this, right? So that is for that. Now, but there was also lots of time. Hyperparameter tuning. So, what's hyperparameter tuning? Hyperparameter tuning is the process of optimizing the settings of hyperparameter that control how machine learning model learn from data. Control how machine learning model learn from data. Someone said something today, was talking about adaptive, like you're developing something to be adaptive. Right? You know that without data set, AI won't do anything. You have to train something on it. You have to put something to train. So, and then also have pre-trained data sets, something that have been pre-trained before, right? And then without human beings, AI won't come. Because it's we that are doing those stuff. So this is where hyperparameter tuning is coming from. Then we have parameters, we have upper parameters, right? Upper parameters. So we have learn automatically during training and then set manually before training begins. The weight in linear, all this is just English. I just put it there. You can go to it in your LMS. Just go to it, play with it, and see, understand what you're doing. But one thing that we need for parameter tuning is the N estimator. You can as well say estimators, combination of number of trees. So we're using edge boost, for example, like combining different trees or combining different parameters together, bringing them together. Then why tune up parameter? Why are we doing this? To optimize the model performance, to increase accuracy, the precision, to avoid overfitting, to make the model generalize better to unseen data, Now, we have different tuning method. No, this is week 6. This is week 6. I did this one for my teaching stuff. I don't know if you upgrade it, but you won't see this what I'm doing now. You won't see it inside week 6. What you just see is the code. I want it. I want just to explain. I want us to understand what we are doing before you want the code, right? So it's Yetunde or Yetunde. So I want just to understand something. So we can tune our parameters manually. You can tune it manually. Then there's something, I don't know if you've heard or if you have been about AutoML. AutoML. Some of us that are using MacBook, AutoML will work perfectly before it starts fine-tuning it. So what AutoML do is it will do the preprocessing itself. It will do the data cleaning. AutoML to do the data cleaning, only just to feed data inside. To do everything, then it will now look for the best algorithm. To look for it, do the parameter tuning and everything, and it will just give you the result. Right? You can look into it. You can look into it. It's a research. I want to see if we can do it before, but because of my system, you do the settings like so. Now, manual tuning is manually adjusting one or two parameters in your code, adjusting it. Then we have the grid search CV. Grid search CV. You can look into it, read about it. It's also search over a fixed grade of value. Fixed grade of value. Explaining this. Then we have randomized search CV. There's random sampling of parameter combination, Bayesian optimization. That is optional. Optional, that is smarter search using a pass results. Then we have Hyperparameter 3 of passing estimator, advanced probability modeling. What I like, one thing I used to use, or I like doing manual tuning, and I think I like using grid search CV, random search CV, depending on what I'm doing. Like if a client is, you must use so algorithm, or your guy or boss, anywhere you're working, they want so algorithm, maybe based on what they heard outside from, maybe they travel for conference or anything, and like, this algorithm is working fine. And so they will apply to their company, they will do something. You want to optimize our work, we want to add it to this website, you want to add so you must use this model. Then that is when you have to start looking for different hyperparameter tuning, like method. You have to start looking for it because there are a lot. We have a lot. I was in my research today. I think I saw about 20. Then there's one I was trying to use. If you open that week 6 on your LMS, you see, as I was to like add Python ignore, Python warning. So I shouldn't be showing all those warning when I'm trying to warn it. Like Python warning, just look at it. Like you can add it to your first code. So it will be showing all those warning. So this is where parameter tuning is coming. You have to tune and tune and tune. And parameter tuning, you have to be careful again. It takes time because somehow it works with computational resources, computational calls. It takes time to run. And apart from that, it can lead your system to deadlock. That's when you see maybe system crash, right? And this is where you will now be needing Google Colab, or you'll be needing AI system to work with. So for this class, we make sure we minimize the parameter tuning the codes. We make sure we minimize it, right? Make sure we do all the stuff. So these are these things that as I'm saying all this stuff is not inside this slide, or it's not inside this code, but just have it at the back of your head in your mind. Just have it. Just know that, oh, Mr. Blessing have said this. I need to be careful when I'm tuning my code. You can search. Just make sure, as anything I'm saying, do your research. Go online. Can this thing cause also? Make sure you do your research. Okay. And sometimes anytime I say anything, I will make sure I still go back. Oh, this thing, is it correct? It's not correct. That's why sometimes you see me still refining, working on my code over and over again. Now we have the first one, basic manual tuning. We already have the code, but let me explain. So let's manually tune one or two key parameters to see the effect of this edge boost that we'll be working with. I'll be working with edge boost. Then we have, I think 73 up there. Now, 73, and we said hyperparameter just to tune, just to do the setting, maybe to increase the something, but it's not all hyperparameter tuning that can increase your work, or like can increase the model, the performance of the model. It's not all hyperparameter tuning, because I put it there, right? So we have for this one now, the normal libraries for edge boost and the normal classification reports, right? Then the normal how do you calling it, sklearn matrix, seaborn visualization, and then matplotlib still for your visualization. Now, manually tuning your model. Look at it. In our model, that SG boost up there, I want you just put SG boost, just call the SG boost, do your normal what they call it, put your S train and Y train, or don't put anything inside, right? Am I right? If you are following me, you want to understand that is to say don't put anything inside. Just call your SG boost classifier and put open bracket and close bracket, right? Like, I think it's able to write code on Google Colab because of the system requirements. Yes. But because of internet, that's why we're not using Google Colab. And sometimes Google Colab, but just try everything you want to do. Right. Tell me, hey, again, let me see. Somebody asked me a question. I got the data set. I want to use Google Colab. I don't know how to use Google Colab. Get your data set, put it on your Google Drive. Right. If you want to use Google Colab, if you have internet, everything is working fine. Get your data set, put it on Google Drive. Then you'll be able to connect to work. Right. Anything you're getting, put it on Google Drive. We also have another system now. We have different platform that you can just write a single code, even on Jupyter Notebook. They will also have Jupyter Lab that is working like Google Colab. Jupyter Lab 2 that is working like Cargo. That is GPS. Working like Cargo. All these things, one line of code. Do your research. Well, because of our gas and people that are still learning, like they're learning from scratch. That is why we're doing it like this. But I know we have gas on this place. Oga pata pata. Again, somebody asked a question last week about VS Code. Yes, you can use VS Code. Isaac taught us how to push code. And again, you can use Jupyter Notebook. Jupyter Notebook have its own command prompt. It's called Anaconda prompt. You can use it to push your code, right? Anaconda prompt. Also, can something as big as ChatGPT be trained on Google Colab? ChatGPT on Google Colab. Hey, you need AI computer resources. Everything when we get to LLM, maybe deep learning models, you will now, that's why we see now you need more system, like more requirements for your stuff. I think yes. Like, yeah, ChatGPT is just a name, but something that is working on ChatGPT, the backend, the model that is working is bet for ChatGPT. Transformer. We call it transformer. It's more transformer model. Yeah, patches. It's like, go and do your research, please. Now, please let me, because of our time, I just have to explain this one, then we'll try it on our system. So now we have, for this part, this is where the something is coming from. We have n estimator 200. So this n estimator is telling me that this is just manually something. It's telling me that, please, for SG boost, it has few trees, but I need 200 trees. 200 trees, right? For some of you that your system is low, don't put 200, you can put 100. You know yourself that your system is slow. You know yourself that your system is low. Okay? From the depth of your heart, you can change this one to 100. But if you're 200 and it work, there's no problem. Then the maximum depth, Isaac was talking about 3. Yeah, you do like yes, no, decision 3, yes, no, and the likes. So please, this maximum depth say go 5 times. deeper. Don't go more than 5 times in the tree. So this 200 is the estimators of different combination of trees, bring them together. All those trees you see, all these models, bring them together, the algorithm, join them together. Then they use label encoder, make it false, not true. I put description under. Then the log loss, put description under, but we don't need this too. But sometimes, somehow you need it. And the random states reproducing, make sure everything is set for 52. So this is more of a pattern tuning. Just these two stuff, the n estimator and the mass depth. N estimator and the mass depth. This is what we need. Then when we are done, still come back to your fitting. Like you have to just do the code up. If a pattern tuning, just look for a place to put your pattern tuning. Just put your own code there. Just put it there, right? And then come back, fit it, train. After you have trained, you test. So training, your testing should give you now 74. When we did this, we have 74% accuracy. 74% accuracy. I'm saving a core. 74% accuracy. So if you have it on your something again, you can just try to run it. I know you have run it already, but I'm just explaining. What all this stuff is doing. What is the specification of your system? I want to upgrade, make my system not crash. No, it won't crash. This is where there's a part. I'll get to a part. I'll just tell you should not run it. So it should take long, so it not lead to deadlock. Still not lead to deadlock because it takes stuff, take computational costs, the resources. Okay, as you said, the line of code and I'm using, I knew the model behind it would be fire. So this is for manual tuning. Now look at this manual tuning. And now I want, if you have run this part, I've explained all these things. Okay, use label encoder first, prevent warning message in pure version of XGBoost. Then specify the evaluation matrix to use during training. Again, if you want to use ChatGPT, I'm not against ChatGPT, but know how to use ChatGPT, right? Know how to use LLM, Copilot, somebody mentioned GOAT or something like that. Know how to use it. Now, if I see somebody code and I want to how can I apply a parameter to do something? One thing I'll just do is I'll just go to the data, where it started importing using that library, logistic regression. Then when it finish, when it shows me the evaluation performance, right, and the confusion matrix, I just copy those code out. I'll put it in ChatGPT. I'll now please, where can I apply a parameter tuning? Just give me the best parameter tuning with this code. Then when it's done, I'll copy it back down. So I'll be seeing when I apply a parameter tuning and when I do not apply a parameter tuning. If you're with me, say yeah. If you're with me, say yeah. I'm giving us code Jara. Then hey, I said something that try this. Let's say you can increase or decrease those values. Can increase or decrease the value. Now, somebody should try 300 estimator, all the trees. Let us have 300 trees. Then the maximum depth should be 6. Another person, if you know from the depth of your heart that this system is very, very slow and it won't give you a result sharp. Change this one to 100. Then the maximum depth should be maybe 3. Should not be 3. Then try deeper trees. Then let us see. Don't go deeper trees. Don't try deeper trees. Let us see what it's going to give you. So with time, can you try it? If you have the code already, and then for some of you that have run it, just look for a space. Do you know how to look for a space between the place? Those places like B after the code. Those places on your keyboard, B to generate, to give you 2 space, and then you are good to go. You're good to go. For parameter, yeah. I said from XGBoost. I don't know if you have the code for Edge Boost. The one the week 5, if it's we're in week 5, just Edge Boost, copy the code, so import so from sklen, import sgboost, right? Copy the classifier, copy the, let me show you, so I know what you're doing. Then for some of you that have written the code, like, do more space down, change the estimator to 300 or 100, then the maximum depth of the tree, change it to 5. So this is more of a pattern. This is where work is actually in ALML. This is where work is. I don't like this data set. Oh, this thing is overfitting. Oh, how did I get 90? How did I get 100? What if I apply this something? What if I minus this something? This is where the work is actually. Well, ChatGPT can help, but know the foundation. Even though you want to ChatGPT, know the foundation, know what you are doing, understand what you are doing. Understanding matter. I used to see something. If the foundation is destroyed, what would the is it the righteous or what would the AI engineer do? So just know what you are doing. Now, this is what I said. Or if you want to, from here, from SK, assemble, import random forest. For some of you, maybe it's SGBoost. Copy this part out. Copy when it was training, the model when it is training. Copy this part too when it's predicting. Though you don't need all this symbol, you can just go to predict actually. Then copy this part, this classification performance out. Then the confusion matrix too, all this explanation, the confusion matrix, just copy it and put it there. Then prompt your ChatGPT. Hello, Oga, how you doing? Can you, from this code, please apply hyperparameter tuning or help with hyperparameter tuning to see if I can increase my something. Then just in the side, this very tree, just in the side there, just press BB, like it will create a new space for you. Copy and paste the code there. Then ask ChatGPT to explain those code line by line. I've explained it, yes, but still ask to explain it for you to understand more. Or come back to this video or the first one, the song, just ask for explanation. That's what I want to say. That's what I want to say, so you understand what you're doing. Then paste and let us see what it's going to give you. How will ChatGPT set your laptop on fire? Smarty. We have used ChatGPT too much. Please, I'm not seeing the line of code you are using. Are you not seeing my line of code? Are you on? You should guess you are on LMS. Go there, copy with 5 code from random forest. Just go scroll down to from random forest. Isaac, where are you? Isaac, there is one. For okay. You have time, but I don't want to also. It's not ChatGPT, but I like using it for some of my work. It's smart. Something of 2 years. That took me 2 years. Now I can use like let me say 10 minutes, 20 minutes, 30 minutes, do my work, finish everything, and do my research sharp, right? Because I know what I'm doing. But all this one is explanation. Now that's for that. I'm waiting for someone that will change this 1 to 100 or to 200 or 300 in this estimator here, this manual tuning here. I'm waiting for someone that will change it and run. Let us see what it's going to give us. If you want to go for. So that's for that. Now we also have another type of hyperparameter tuning. No need now. Why do you want to sit down and learn coding? It's simple. I won't give you a expo. I can't run any code now as I keep getting cell not executed due to pending input in Jupyter notebook. How do I rectify this, please? Cell not executed due to impending inputs. Cell not executed is, do you run your code from top? Do you run your code from top? First, there's a data set inside your folder for piece. Your data set inside your folder, you run your code from top. If you have any error, instead of, because of time, you still have a lot to see. Use ChatGPT. Use any AI. Ask questions from it. This is what I'm getting. Let it teach you. Then if it's now complicated, this you can bring it here. There's no how. We'll set it on fire. There's no how, right. I will set it on fire. There's nothing that we cannot do. Somebody messaged me on the one of my platform, and the person has been messaging since last week, messaging. I was like, oh, let's have a meeting. Then I was just one line of code, and I was like, God, now another person message again, just one line of code. So if you have been following something, you shouldn't have error. At least by now, you shouldn't have error. Yeah, I'm making use 5. I'm using week 6. Yeah, just go to week 6. It's on canvas. This code is on canvas. 4. Okay, correct. Thank you. Now we also have another type of hyperparameter tuning. When you are done with this class, this one of the coded and yeah, I say one of the coded parts of AI, and it's one of the sweetest part of AI. Yeah, when you're playing with model, one of the sweetest and codest parts, right? So we also have another type of hyperparameter tuning. We have Gantt charts, Gantt charts CV. So Gantt charts CV is a method in scikit-learn that automatically searches for the best combination of hyperparameters. So the same thing as your normal manual editing. So now we have parameter grid. This is it now. You have parameter grid, n estimator. That first one, you just 300. We set it as 300 or 200. The first one there, manual. You just set it as 300. Now, all my estimators, I have 100 here, I have 200 here. I can as well say comma 300, comma 400, analyze. So what this Gantt charts TV does is it will just look for the best. It will go for this one, and look for the best for my work. Then, then for the maximum depth, 100 is set for 3. Hey, yes, you see now. Like based on that, I've been writing code. I like, okay, 100 trees. 100 trees is 3, or let's say 2, between 2 and 3. Like 200, 5, or maybe let's also say 6. Yes. Then the learning rate is 0.05. Learning rate most times is used in deep learning model. So, and then the lower the learning rate, I think the cooler the model is going to learn. So learning rate means that this learn in this rate is 0.05, learn in this rate is 0.01. Though we don't need it. What we need is just this to stop. But sometimes you need to work with this learning rate, because if you don't put this learning rate, sometimes you will be having maybe overfitting or underfitting. Do your research. What's the meaning of overfitting, and what is the meaning of underfitting? Right. So then we have the set of grid charts. Still we have the grid search CV. The estimator should now be this one. Like we're now bringing it back just for the prediction, bringing it back. Then the parameter grade is called to parameter grade, is calling its accuracy, and then the CV is equal to 5. So what the CV is doing is this is K-food. K-food. You will be hearing new stuff. It's part of research. When you are done, you'll be hearing new stuff, new code, K-fold 5. Why are we using 5? So it just the K-fold is dividing my data set into training, into testing, and validation. That I want 4 and I want 1 also. 4, 4, 1, 1, or 4, 4, 1. It's still dividing my data set, the train data set. We have the variables, have the end job. All this stuff, if you are working with your model, you'll be seeing them and you can be playing with them. Then fit your grid search. You fit it. And this one is for, okay, this one is grid search. Then we have 73. After I've done, when I run this code, I still have 73. We will have been looking at it from here. The best parameters, the learning rate is 0.05, it peaks 0.5. We can't use, actually, we can't use 0.1. It will be learning too fast. The model needs to calm down. Then the maximum depth is 5. The N estimator is 100. Estimator is 100. It's beautiful. I like this stuff. You know, I'm looking at it. I like this stuff. It will be looking strange to some people. Like now, it's looking strange. If you have your code, just run it. Run your code. But make sure you do your research. Do your research. Run it over again. Ask questions. Maybe later you can be asking questions. But I want to finish all the type of parameter tuning. So I want the next week is we're just going to deployment. I will afford the code. Then I will just teach us how to deploy. Then, if possible, maybe 1 hour deployment. The next hour is everybody bring your code. Do something. Let us start fine tuning. You ask questions, right? Ask questions. Well, teach us how to run our code, how to deploy our something next. Our AI model now that we have trained next week. He said what he's teaching now is not is there, is in week 6, so everything is inside though. It's just the write-up that is not in week 6. It's inside. For the first time. Two work together. You have been following, no, but for the first time. Okay. This is what I will say. But each and every one of you understand to confusion matrix. You understand to confusion matrix. Your own is, if possible, so I will not waste our time. Just pack all your code, put it in, just put it in ChatGPT. Say, please, where is a parameter tuning? Just apply it. Apply a parameter tuning and give me the name of the parameter tuning. Right? It is where. Felicia, hope you have been following because I want everybody to understand. It's actually simple, very, very simple. I want everybody to understand and I want everybody to follow. I don't want some people have kept quiet now. They're already enjoying themselves. They've run the code and they're enjoying themselves. But understanding Oshikoko is very, very important in anything you are doing. So Felicia, there's no problem. Make sure you look at go over this video over and over again. It's not a problem. I've explained everything. I've explained. So it's not a problem at all. I use grid search change some parameters. The output is either increasing by 0.3 or decreasing. Yes, nice work. It's hard work, Paul. That's great. That's wonderful. The code is there. Mr. Shevin, the code is there. Yes. Adidayo. Yeah, sure. But some people are already working on the code. Pretty sure. Some people are already working on the code, and it's on the platform too. Understand you, Shikoko. So I can just do one code and give you. We are going too far. Everybody go to LinkedIn, start posting. I ran this code, I did this one, but you understand? And so I'm just giving all the secrets. The something is still go back, still like copy one code one by one, put it in ChatGPT, ask question. I can't answer all the question. I can't answer the question, even though I know. And some of the question I don't know, I will still ask. I'll still go on, like do my research. Right. But let me just show us very, very quickly. Then maybe you can be asking me question, then we'll be I'll be answering you. So this one is for grid search, then still have 73. Very low. I don't like it. So it's just picking, looking for the best estimator. Then we have the random search CV. So we say it's smarter, it's faster, and then is smarter and faster. So it's an hyperparameter tuning technique that randomly sample combination of a parameter for specified distribution, right? So this just 8. Is this the same thing? 100 raised 100, 300, 400. The depth 4, 3, 4, 5, 6, 8. The learning rate is 0.05, 0.01, 0.05, 0.01, 0.02. Then looking at it, I think it's going to pick the second one. The sample, the subsample, the collapse sample, the core sample by 3, the gamma, the reg lambda. The description of everything. Now this gave me 88, 78, 78. You see that something is already increasing. But in the recent, if it is for me, I don't need. Don't be confused. So if it's me recent, I just need my n estimator and my maximum depth. Why do I need it? I'll not be fine-tuning manually. I'll not be fine-tuning. Okay, what if I put 100? Then I put, maybe I want to use the new rate. What if I put 0.001? What of this? Something should go deeper. So the deeper the tree is going deeper, the deeper the something is learning, is going to train the pick patterns, train the data set very well, but it will take long, right? It will take long before something, because it's learning, it's picking those things. Okay, this thing I not pick before, this thing I don't see before, let me work on it. Okay, what is missing? Now you can be seeing now this 78 accuracy for random search CV, and this one is already increasing now, 70, 64. But last time it was 50 something. I think we have 50 something there. Then support 99, 55, it's still 154. That is for random search. I'll update us with this explanation. Based on this explanation. Then we also have another type of hyperparameter tuning up to now. If you are doing competition, all this competition on the cargo, you want to use model, search for something, and then paste it and win $5,000, $1,000. I'll be working on this something most times. To increase my accuracy, most times I use Optina, right? Then random search to just fine-tune the model to make sure the model learn where the likes. Now, reason why we're still having, let me show you for this Optina, what do we have here? This, everything here is objective, right? This is the code here. It's still the same thing, 100, 200, 308, just you can fine-tune it. You can change one or two stuff. What if I do this one thing? What if I do it like this? What's this one giving us? All this warning is nothing. All this warning is nothing. All this warning you're looking at is because the reason why I'm saying warning is because I did not apply it from I know on the code. Let me show us. I'm supposed to add import warnings. That is to say, ignore every warnings. I'm supposed to add it in my code. I think I know add it in this fixie that we are going to upgrade it and forward. So it's nothing. So now, what do we have here? We have 76 up to now, 76. Then up to now, okay, yeah, 76. Random search is okay, up to now is 76. Random search is 71. Base search is 73. Manual tuning is 73. And we also have the upper works. That is this one. This one took long before it run on my system. Took long. What is this one? 73. 73. So the best is still up to now. The best is up to now. So or random search or random search. So now I can't see any estimator on the code. This scroll down, BO Igwe. I'm confused from here. Hackathon. Yeah, hackathon. Yeah, we use random search, we use Optina and likes. Okay, now if you have do you have time for question? If you have any question, so what we'll do is by next week we are downloading I'll show us how to save the model in week 5. It's already in week 5. Let me show us in week 5. I add something like this. What is this? Yeah. When I train, um, when I train SG Boost, it gave me 77. I was like, I'm okay. I'm okay with it. Let me work with it. Then with this import job lib.dump, I need to save this my SG model. Save it for me. So it's saving this SG for me. SG Boost diabetes model.pkl. This is what I want to use to develop my system. I want you to develop my system. Now, somebody mentioned something last week. Talked about that we can use Flask. Somebody said we can use Streamlit. Yeah, Streamlit is instead of using what do you call it? HTML. You can still put HTML, CSS, all these small code that Isaac was showing us. You can still put it, but this model will be doing everything for us. This AI model now. I'm calling it AI. Will doing everything for us in week 6. In week 5 is there. You can just scroll down to I think to line 29. If I don't know, we'll scroll down to line 29. And this is week 6. Yeah, this is week 6. This is week 6. Okay, if you have any question, maybe from week, let's see from week 5. You can ask a question. Let's see if you can trash it. We have just 10 minutes to the end of the class, and we're good to go. Why did you say Optina was the best? We had SG Boost with 78. No, I mean, I don't say it's the best. Like for this code, bless it, for this work, for me, Optina is the best. And I can still add, and in machine learning or AI, you can say something is the best actually. You can just say something work is perform better. It perform better when I apply accuracy, right? When I apply an Optina to the something to tuning to my code, I can say this thing work better. I can use it to write my paper. I can use it to write maybe research, put it online that I did something and I publish it, like, based on what I did with this data set. Now let me give us data. Let me give us something else. Let me tell you why everything is in 70 something. Do you want to know? If you want to know, say yeah. If you are with me, if you are still with me, say yeah. Because everybody now, they're now cold. This is not different though. What am I seeing like this? Yeah. Correct. Spirit of flame, where have you been? Where's Isaac? Isaac whined me one of the class. So I'll note you down. I note your name down. Okay. So in roots, yeah, correct. Isaac is not different. It's not different. It's simple. It's not different at all. It's very, very simple. Very, very simple. Just look at week 5 and look at where Hyperparameter tuning is coming in. You know what? That's Steven. But if I make me to laugh. Okay. Um Again, I'll repeat it again. Hyperparameter tuning, we are just setting, repeating, doing one or two stuff with the code, and we are done with. If because like a good number of class followed me to confusion matrix, I can as well use that confusion matrix. Like from that confusion matrix, right? When I get my accuracy, precision, F1 score with 7 something, I can just develop my model, like develop a system. Are you with me? I can develop a system with it, sharp, and I am good to go. But I don't want to keep people. Eh, um, in medicine, this model, something percent, if I want to generalize it on validation, if I want to like use my validation data set, I can be having like 60 something. That is to say the model can be slow or is underfitting or overfitting. That is why we're bringing in hyperparameter tuning to see, okay, this model, what can I do to it? That is, as I said, you can use LLM. Okay, this is where I've reached in my code. Go to ChatGPT. I'm giving us Jara now. I'm giving us Jara. Go to ChatGPT. Copy those code. If you want, if possible, you can copy it from import from the first part where you start doing when you start importing your data set. Copy everything to confusion matrix and say, this is the code. Alpha, can you help me apply hyperparameter tuning? This is what I'm. Can you put your result there? Right. So it will show you. You already know the code. It just show you that this is where I'm applying hyperparameter tuning. It just show you. And why you apply hyperparameter tuning? Most time is to be inside your classifier. Logistic regression, close bracket, open bracket, close bracket. Now, inside of putting close bracket, open bracket, you put the n estimator, put everything inside. That please tune this model for me. Tune it. I want you to tune it. Simple. And when you start tuning, it's going to increase something. Now, another thing again to increase your accuracy, increase your F1 score, performance of the model is preprocessing. I've said that in the beginning. Preprocessing. Go back to your preprocessing. Did I preprocess my data set well? I've taught us that we did it well. Everything is zero, yeah. But is there any other stuff? I said standard scalar. Do not do. Is there another type of something I can apply to this preprocessing? Then, thirdly, another way again you can apply your something is using smooth. What if I balance my data set? Is ChatGPT allowing your hackathon? I don't know. It's not allowed though. You can now say, what of if I yes, you can use in hackathons, you can use ChatGPT, they will allow you. You can use ChatGPT to do your stuff, but don't use it to maybe the code now. You're not saying ChatGPT. Just understand when you understand what you're doing. ChatGPT just to help you understand what you're doing. Now you can use smooth and balance data sets, right? And see what is going to give you, or you use Classway, you use all this stuff. I want to say Yoruba. I've said plenty things, but it's not that plenty. I've said plenty things, and I believe we are good to go. Okay, we just have like 4 minutes more. I wanted to show you one of the model I developed. The last upper class was I showed us flags. Then I use Streamlit again. I'll show us where the model is coming from, the SG boost. I just save the SG boost. Again, my assignment again, I think I need to give assignment. Your N estimator, go and change it. Change your N estimator, change it to maybe 100, change it to 200, change it to 200. Then when you're done, apply different models. We are using SG boost now. Apply different type of model. You discover that what you're saying here is different from what the answer you are getting in your own laptop. Hence, some of you might be able to be getting higher accuracy, higher scores and everything in your own laptop. But my own laptop, what you're saying, because my laptop, I should not say, I don't know type of laptop I'm using currently, right? I'm getting this something. So all this stuff, begin to now look at it. Okay, AI model, what do they want? Computational cores, the resources that I need to be careful with parameter tuning. Okay, so okay, why am I getting this something and I'm getting this something? So all this stuff like that, this is where you need to now be considering, okay, this is what I need to do, this is what I need, this is what I want. Like there's a client that contacts me one time like that. They said they'll be paying me so amount, and I said I should give them my bills. They want to work on deep learning model. And when I send my bills, I add laptop to it, like a higher laptop with something. I don't want to run my something on cloud, right? Because most times I find myself in a remote area where I want to be calm, do my stuff. I don't want to like village place. I don't want to be like I need internet, people not be disturbing me. When I send my bills, they're like, this is too much. Hey, It will be like that. It gets so all this is just research. All this is research. We are good to go. Please, if you have this code, maybe we'll do the update of all this explanation again on the LNS, on LMS. We'll do the upgrade. Um, Work with it, play with it over and over again, ask questions because I know we are rounding up already. And next week, I teach you how to download the model that we have trained. Teach us with create like a stream it or flag something, then apply it on other different type of data sets, and we are good to go. Thank you very much for your time. Okay, Dada Steven, you are getting the gist now. Correct. So don't be confused. It's very, very easy. Because the one is calm down, look for someone that will just put you through. Oh, this is what I'm getting. Someone that I've worked on it before. Tell, oh, this is why it is like this. This is why it's like this. Right. So thank you very much. Thank you for your time. Thank you for the people that are still holding forth. Like, I will not give up. I will not give up. I'm very, very happy. Like I'm still seeing some people's name. Right. So thank you very much. You do upgrade so we can follow. What upgrade should I do? Thank you, Blessing. Thank you, Eniola. Where's my friend Isaac? Where are you? Yeah, Mr. Shegun, thank you. Thank you. Please work on this something all over and over again. Understand how it is. It's very, very simple, it's very, very easy. And then if you are done your something up to confusion matrix, I know how to explain. If possible, say, go and be bagging on LinkedIn, bag anywhere. Yes, I'm now a machine learning engineer. Yeah, thank you very much, Mr. Mano. Thank you. Yeah, good night. Thank you.